Great, thanks very much. And thanks everybody for coming in today to talk about Azure Synapse with me. I've got my email in here a few times, so anybody who has any questions, the last time I gave a talk about a month ago, there were some in the chat and they'd asked for slides and things. I don't get access to the chat afterwards, so if you could just send me an email directly, I'd appreciate that. And then I can get you, some content, or if you have any questions, I can answer them too. So without further ado, I am excited to talk about Azure Synapse, this being MS Build 2020 this week, and Azure Synapse public preview going out. Some of the great new features, we'll cover some of those, and some of the more traditional data warehouse topics, and sort of how we approach them from the Azure standpoint, and then what Synapse will do for those data warehouses. So, as I mentioned, here we go. Okay. My name is Christopher Erlis. I'm a Microsoft Azure Data Specialist, and so I help customers with their architectures of Azure and give presentations and demos and things like that. And so, once again, emails at the bottom there. Appreciate any follows, likes, YouTube, that kind of stuff really helps to motivate things, and help put out some additional content. So, feel free to reach out with any questions. So from an overview standpoint, today we're going to kind of talk about, the modern data warehouse as we see it in Azure today, kind of rolling into Synapse and what the implications will be there. Some of the common data warehouse challenges that we face in sort of the more modern times, if you will. The SQL Data Warehouse capabilities, as it was previously named, and really what that Azure Synapse Analytics really means, because it goes beyond just those base capabilities of Azure SQL Data Warehouse. It's more than just a rename. It's a complete redesign. And we're going to talk about what came out in the public preview that was announced yesterday, and hopefully we have a little bit of time for demo. I plan to save just a bit there so we can kind of get into that, and then just a little bit of time for questions. So before we kick things off, just very, very straightforward, right? There are no right or wrong solutions, and only the optimal ones for your specific use cases. So when we talk about a specific technology, Microsoft wants to be a platform of choice. They want to be able to give you the capability to use as many products as you can on that platform. And in this case, when we talk about Azure Synapse, 7 months ago, it was named Azure SQL Data Warehouse, and that product has graduated, and now we call it Azure Synapse, and beyond just that compute engine for massively parallel processing, we're now offering a whole lot more capability there. So the product has been renamed, it has graduated to multiple generations, but the core product is there. And when if we talked about this conversation a year ago, we would have no idea that this was on the horizon. And so just kind of be mindful of that, that these things do evolve over time. So jumping in to the modern data warehouse as we see it today, essentially from left to right, you've got your sources, in various ways to grab data. We're ingesting it, then we're going to store it in our, whether it be a data lake or some kind of blob storage or some kind of transactional system. We're going to do some transformation. We're going to do some aggregation. We're going to pull all that data together, and then we're going to serve it up so that it's ready for the presentation layer, whether the tools be in Power BI, on-prem, in the cloud, a lot of different capabilities and options there. And when we dig into those sources, right? So we have the more traditional ERP systems, very transactional. They generally fall in the form of some kind of a batch load when we talk about data warehousing and loading that data. But now we're starting to see more and more of these unstructured data sources, like from social networks and IoT. But then, of course, there's that legacy and historical data that we have to figure out how to get that up into Azure when we have massive volumes of it, or it just doesn't make sense to send it over the wire. And of course, with SaaS applications becoming more and more predominant, whether it be something like a QuickBooks Online or a Marketo or Salesforce, just so many options there. We really want to have the ability to pull that data in and make it part of our overall data warehousing strategy. As we dive directly into that ingestion piece, we basically have three main ways of pulling in data, and that'd be bulk, stream, and batch. And so, some overall services here that we would consider when we start to look at how we want to pull that data in. And sort of digging in a little bit, when we look at bulk, Azure Data Box is a great option. So, say we have, 50 terabytes of data still sitting on-prem from our old Oracle data warehouse, or a bunch of transactional data that was sitting in a mainframe from back in the day. And we want to come up with a fast, efficient way to get that data up into Azure. Essentially, you order a data box. You can see the various sizes there. We send a box to you. You fill it through SMB or an NTP share, and then basically send it back to us. I'm sorry, NFS, not NTP. And then you send it back to us. And then the data gets automatically put into your storage account. It is encrypted end to end with 256-bit encryption. So once you load it onto the box, it gets sent to us. It's drop proof and spill proof and all those kinds of things. We plug it into our data center and it gets loaded into an Azure storage account. We never see it. Now, there are a couple other flavors of the Azure Data Box that could come in very handy for pulling some data on-prem if time isn't necessarily of an issue, or you have some other use cases. So when we look at something like Azure Data Box Gateway, this is a virtual appliance that you load into your VMware system as a virtual machine, essentially, that gives you a direct connection to that storage account that you want the data to land in. So you can, again, connect this to an NFS or an SMB share in your internal network and have it sync the data going across into the Azure storage account. And then Azure Data Box Edge is an even more interesting use case, where this is actually a physical appliance that you can put into your network. It is enabled with FPGA controllers, where you're able to actually run some more simple anomaly detection and things like that against machine learning models that you've developed on the suite of ML tools in Azure. And it'll actually run some of those near real-time situations. So if you're using it for, say, a quality control device, and you're using some of our AI capabilities to detect an anomaly in a manufactured item or something like that, you now have this capability to more quickly identify if there's a challenge or a problem with your production line or your quality control process, and be able to send out alerts even quicker than having to send the data up all the way up into Azure. Past the bulk, we start looking at stream, right? This is becoming much more prevalent when we start talking about IoT or our social networking, and whether you're streaming data out of a mainframe that sits on-prem, that you want to get the data into Azure. There's some great use cases to be able to send that data up, and those main tools would be things along the lines of Event Hubs or IoT Hub. Kafka can be run on HD Insight. There's also third-party tools that exist in the Azure platform that can do a managed Kafka instance for you, where you don't have to manage the Hadoop infrastructure inside of Azure. And then, of course, Databricks is becoming much more popular on a bunch of different ways, whether it be data engineering or data science or data streaming and data analytics, having an easier interface to use for compute on demand and be able to tackle a lot of different workload types. And then we move into things like batch, where, this is more the traditional data warehouse discussion, and you can see we've got the legacy on-prem tools, some of which are available in the cloud. So you can run your SSIS packages through Azure Data Factory. Informatica has an iPaaS offering where you set up some virtual clusters in the background, and the majority of the interface is hands-off. Talend, you could run in a virtual machine. Obviously there's a bunch of legacy ETL tools out there, but then of course we have the first party tool, the Microsoft product Azure Data Factory, which gives you that the ability to orchestrate and transform data in a purely cloud environment, and has significant connectivity to the various Azure assets that can be deployed. And of course, Azure Databricks with Spark running in the background. Now, some of the times I hear questions as to whether a customer should use Data Factory or Databricks, and really it depends on the comfort of the team. They're both very powerful products. Databricks, I think, gives you a little more capability because it is a code environment and you're doing the majority of the work with code, whereas Data Factory is primarily designed to be a low code, no code option. There are ways to insert code and run a Databricks notebook or a Spark notebook as part of your Data Factory pipeline, but largely based on the idea that you're getting a quicker GUI interface with some wizards and things like that. And Microsoft's obviously famous for their wizards. So moving on from that ingestion piece, once we've got our data coming over the pipe, and we need to figure out where we're going to put it, right? And so essentially, we've got some choices here. And the majority of the design sessions that I do with customers when we're architecting out a data solution for them, the majority of the time we're landing in a data lake. And that data lake is going to have multiple zones. You're going to have that raw landing zone where the data sits there. Generally, you're going to have a staging zone that follows, and that's as the data gets moved around and merged together, and whatever needs to be done to it, you can do that in your staging zone, and then ultimately you're going to push that out to the curated zone or that finished zone, depending on what terminology you use. And there are multiple ways to do it. I've seen up to 5 different zones, and trusted and curated and staged and quality and all these things. But it's really dependent on the environment and the way that you guys hope to achieve the data warehousing goals that you have for the organization. But then we have instances where we have things like transactional data that's already sitting in a RDBMS on-prem, and you want to keep that structure. You don't want to break it apart. Maybe you've already created your schema on-prem that you want to use for your presentation layer, and you could use your storage layer as something like a SQL database or a Cosmos. Cosmos is obviously multimodal, multi-master. You can use for SQL workloads, but then it also has the ability to do a whole bunch of other stuff with APIs for things like graph and DocDB and those types of things. So a lot of options there, and it kind of depends on how you're serving that data up and what the requirements are. So if you need something that's going to be replicated around the world in sub 10 milliseconds, then Cosmos might be a good answer for you. But then of course you've got a limit on how large the objects can be. You can only have an object size of 2 meg or smaller, right? So it really is designed for very small chunks of data to be replicated around the world. Great for things like social networks or some kind of an application on a smartphone, right? So kind of depends on your situation. Again, we do have the question commonly as to whether I need a data lake. And the answer is no, do not need a data lake. But when you think about as we start to ingest different types of data, and we have to consider, are we going to ever need a streaming workload, or are we ever going to need anything that's unstructured, PDF files or images or video or anything like that? It's really good to have that data lake, to have that flexibility down the road. And data lake storage is very inexpensive, and it gives you the ability to really consider where you can go with it, running long-term analytics and things like that on your data, and it gives you a lot more flexibility than, say, having a structured RDBMS in the cloud. So after we've set up our storage and we've got our data running there, now we're going to start talking about moving the data around and merging it together and doing some of that data processing, right? And so again, Data Factory being top of mind, where it is a Microsoft developed product. It's the newest, latest, greatest. It's constantly being updated with new services, new features, new capabilities. Some new items just came out in this last week here with easier ways to understand what your pricing will be and different kinds of transforms and things like that. So there's a lot of great capability there. Uh, Not everything is covered with Data Factory, right? It's very similar to SSIS, where you're essentially doing your control flow and your data flow, and that's what happening through pipelines with the orchestration piece, and then obviously the transformation or preparation piece, and there are limited capabilities, and it's just because it's a newer product and not everything can be covered in that single product as it's come out over the last couple of years. So maybe you need to insert some code in there, right, with a notebook running Databricks or HD Insight in the background, or maybe you'd rather do your transformation all in Databricks. I've got a customer right now that is landing their data into Data Lake, and then with Databricks they're going ahead and doing some of the transformation all through code, right? So there's a lot of capability, and kind of, again, depends what you want to do. And again, we talk about HD Insight, Hadoop having a great background in big data resources and a lot of structure, whether we're using Spark clusters or Hive clusters or LLAP clusters, a lot of different options there. But Hadoop and the Microsoft named HD Insight also comes with a cost, right? Because there are seemingly less developers in that space and have great experience with those tools. And so it kind of, again, depends on what the capability is of your workforce as to what the best solution might be. And of course, we have the third-party tools. Again, I mentioned Informatica earlier. Very mature product, been around for a really long time, added a lot of great capability and has a lot of options deeply embedded within Azure for connecting to Azure resources. So now, after we've had a chance to get all our data mashed up and we're good to go, now we're going to set it up into our Snowflake or star schema. And this is really driven by how we want to serve it up and what the volumes of data are we going to use, how quickly do we need to process the data, and this will help us determine what the best tool is to use the serving layer. So whether it be SQL database to save some cost, but at a performance hit, it really depends on what your SLA is and how quickly you need to process that in order to have that schema shaped. And then the other option too is you could use something like an Azure Analysis Services or Power BI for the data model piece. You're loading that directly with, after you've got your transformation inside your data lake and in that trusted zone or your finished zone, you can then load that data into Azure Analysis Services and use that as the backend. So as we serve the data up, we want to present it, right? And so for simplicity's sake, I'm using Power BI as my main example here, but know that there are obviously a lot of third-party tools out there that do reporting, and we've got capability built into both AAS and Power BI called XMLA endpoints. It's much newer in Power BI, but it is available in Azure Analysis Services as well. So when we consider Power BI, we've got the Power BI service, which is in the cloud. It has the visualization style reports or dashboards, if you will, and it has paginated reports for those more finance-driven, reports that we're more familiar with from, years ago, and still finance departments seem to love them. And then we have the Power BI report server, which is that on-premises version of the Power BI service. Now, it is a version of it, but it's actually a totally standalone product. So it's a superset of SSRS. It gets updated on a schedule. It's about 3 times a year. Last I knew, the update schedule was generally February, June, and October. And they add features in when they do those release cycles, and it kind of depends on what your requirements are, because there are oftentimes services that are available in the cloud that gets updated monthly that aren't available in the on-premises version. And there's a possibility, if you're running the on-premises version, a specific feature you're looking for from the cloud version may not be available for some time. It kind of depends on what is priority, what customers are requiring, and how they support that product is muchly dependent on really what the biggest desires from customers are that they're seeing. And then, of course, as I mentioned, with the XMLA endpoints, you've got a choice. You can land that data into a Power BI data model or an Azure Analysis Services data model. In the case of determining which one is better for your environment, I do have a YouTube video out there that I put together on my YouTube channel, but really kind of breaking it down relatively simply. You have the question of security. Azure Analysis Services has finer grained security capability all the way to the object level, whereas Power BI only supports up to row level security, so you don't get column level security or cellular level security in Power BI, but you do in Azure Analysis Services. And the other question is about scale. So when you talk about Power BI, you've got a node of compute that's available to you when you buy a premium node. It's dedicated. That premium node is has multiple tiers, P1, P2, P3, and so forth. But once you go up to that next tier, you're in that tier for at least a month if you can get it moved back down. Whereas Azure Analysis Services, you can scale up or down, in or out on demand, and you're only paying for the consumption that you're using while you're moving, while you're doing that scaling. The other thing is you can actually turn the Azure Analysis Services off. So let's say you're on the East Coast in the US and you only have business hours, say from 7 to 5 Eastern, you can actually turn that service off and the outside the windows, and then you're not paying for the compute, you're only paying for the storage that you're using anywhere. So just some things to think about. And then the piece that gets left out far too often is the governance, data quality, and master data services. And there are quite a few really good third-party services out there. Azure Data Catalog is soon coming out with a version 2, which will be it'll have its own AI features and capability for auto detection of services that you're using, reports and metadata and a lot of information. Whereas the Gen 1 of Data Catalog is just very manual. Still a fine product. It just requires a lot more manual intervention as opposed to Gen 2, which will go out and traverse your Azure workspaces and on premises and pull back some of the information you need there. Now, you've obviously got some leaders in this space, Informatica and Prophecy. Prophecy is soon releasing a PaaS version of their MDM solution, which is a great solution. It runs on Kubernetes. And then what we talked about, the Informatica iPaaS offering. And then finally, some smaller players like Samarchi that are coming up in the space and some great capability out there. I like to say that data warehouse is not complete until you have the governance, data quality, and master data tackled as well. It seems to be one of those things that get left off because it's kind of like backup, where you don't need backup until you need backup. Well, you don't need master data until you need master data. So. Now, as we jump into some of the more common data warehouse challenges and where some of the beginning stages of offering platforms like Synapse came from, generally we ran into a lot of these corporate landmines where, security had to certify a server, and A lot of things were policy driven. It could take 5-6 weeks for you to get a new server in place with all of the patches that needed to be done, all the security updates, and all of the right software on it and the right versions on it. And then once you actually get that server deployed, then you have to put it through maintenance schedules and HAA and DR and backups and all that good stuff, right? And so that's when we start having conversations about whether you want to run those servers on-prem or if you want to run them in an infrastructure as a service offering in VMs and Azure. And then there's the platform as a service offerings, which take away a lot of the requirements here because you're not having to do a lot of that maintenance, and you can spin that server up very, very quickly. You can scale. It's very elastic, right? A lot of capability there. And a lot of this is driven because of the fact that data is evolving, right? I call it the 3 V's of data, where you've got the volumes that are going crazy. I mean, we're talking on zettabyte scales around the world now, as opposed to petabytes or terabytes. The velocity of data, we're much more quickly trying to respond to the demands of business, and they've gone much further past just those batch nightly loads of data warehouses. We need some of that real-time reporting and real-time information delivery. And then of course the variety of data, right? We talked about the social networks, we talked about IoT devices, and you've got your more standard structured data. And the thing is that these 3 arrows are just continually going further and further away from each other. And it makes you really wonder what happened historically, right? So how did you get where you are, and what do you need, right? What's happening right now in our data sources, and then what are we gonna see in the future, right? And so based on some predictive analytics and some of the AI capabilities, we can take the data that we have and the learning that we have, and we can then figure out where we're going with some of this, or at least make some predictions and have a little better information about it. So even if I can get 1% better in my thought process by having some related information in front of me, that just still makes me that much better. And ultimately, each dimension of this data is constantly expanding, and it's going to continue to do so, which just makes our lives that much more challenging. And then the last reason that we started talking about the opportunities of the cloud and where we could go with this is the traditional data warehousing problems, right? So these appliances, these platforms, the Netezas, the Teradatas, the PDWs, the APSs, and all those types of devices were great for relational data and OLAP requirements. They ran those online analytical processing jobs very, very quickly, very efficiently, and they worked great. But they had a fixed set of capabilities. Upgrading them was not easy to do. And now we're starting to see a lot of these go to end of life. Teradata and Netezza are now either having you pay astronomical dollars, some pretty significant support requirements, having you move altogether to their own cloud versions. And these appliances just were not optimized for big data requirements. And so, when we start to look at some of these unstructured and semi-structured sources, the clickstream data, the social networking data, those kinds of things, just really it wasn't designed to handle that type of stuff back in the day. So when we brought out Azure SQL Data Warehouse, it was a great product. It basically took our on-premises massively parallel processing system, being called the APS, and it put it in the cloud. We came out with a Gen 2 about a year and a half later that drastically improved the performance. It gave much more concurrent query support, and we had a lot more flexibility with the platform, so more tightly integrated with the various Azure components that we were using, much more reliable maintenance plans and those kinds of things. And then, of course, from a security standpoint, we are certainly a leader and the leader when it comes to industry-leading compliance and governmental compliance and those types of things. But just for kind of a quick overview, when we start talking about SMP versus MPP, and really what we're doing here is in an SMP standpoint, where using a bunch of CPUs, and we're sharing all that same memory and disk to run those workloads. But then when we spread that out, those analytical jobs across multiple nodes, it gives us that much more capability to be able to spread the load and process that much more data that much more quickly. And so, we've got these 4 worker nodes that are handling the load. And as we look at what the architecture looks like, essentially, you've got a control node that is your quarterback that's distributing the load across the compute nodes, right? And so you've got, doing all the orchestration from the control node standpoint, and telling each of the compute nodes what to do to be able to put that data together and mash it up and return our results. Now, there are some strategies on the best way to handle this, and this will remain true as we lead into Synapse, where you've got a few different table types, and roughly speaking, a hash table type would be used for your fact table, right? And a round robin table type would be used for a staging table, and your replicated tables are good for dimensions, right? And those all depend on the size of the tables and again what you need for performance and throughput here. But just as a general, you can relate the 2 of those together. Sorry, the 3 of those together. And then we mentioned the security features. So when you look at the SQL Data Warehouse now Synapse product, and you compare it against the competitor security landscape, you can see that by far and away we check a lot more boxes than the competition does, and so offers a great amount of security to help those security professionals sleep at night. And then sort of the last really cool feature about SQL Data Warehouse was Polybase, and this allowed us to run jobs against external tables. So if you wanted to hang something off in blob storage or data lake storage, like a CSV file or a Parquet file, and some of the other formats that are pretty much industry standards at this point, you could go ahead and hang that compute off. Hang that file off of your compute. You didn't have to load it into your relational database system. So that could be, a query on the volume of unstructured data inside of your blob storage or your data lake store. And you could do those queries coupled along with the structured data that's in your data warehouse using Polybase to return those results, and you don't have to load that data. It all runs externally. Which gives a lot of flexibility and capability, because then you don't have to worry about schemas and things like that. You can just run it once and know what's happening. So that leads us into Azure Synapse Analytics. And initially, Azure Synapse Analytics, as it was released, was very much a rebranding of the product, a renaming of the product to save some confusion. And then we lumped in some other really great capabilities there for being able to handle things like big data workloads, data warehousing workloads, and the data integration into sort of this common interface. So when we look at what it integrates, we have our management, our security, our monitoring, our data integration, and our big data engine, as well as being able to develop our Power BI reports all in the same interface. So we're doing that using Synapse Pipelines, Synapse Studio, Synapse SQL, and Synapse Spark, all in the same interface. And from a different perspective, you can see you're pulling in your data sources, and now using the 2 different runtimes with all the integration and this one unified platform, now we can do all of that data warehousing work in the same interface instead of having to bounce around to different tools. And then it also integrates nicely with our suite of Azure machine learning tools, so we can actually do some predictive analytics right in the same interface by running Spark notebooks and then using those machine learning tools as an extension of Synapse and output that data to Power BI. So just for a couple of quick, overviews of what we're looking at here, if you're familiar with Azure Data Factory, this interface will look very familiar to you. It's because it's built on the same product. It's just being ported over to Synapse, and so as Azure Data Factory is updated, so will Synapse be updated for its transformation and orchestration piece. But you can see we've got over 85 connectors for on-premises and SaaS-based connectors. We've also got the ability to do more file-based operations, so things like CS flat files or things like that. And then we can also run against a REST API all in the same interface. And then as we do our orchestration and our transformation side of things, again, happening in the same interface, we can create our data flows for Power BI. And you can also run your Spark jobs here as part of the orchestration for your with a notebook file for your data pipelines inside of Synapse. When we look at the development hub, essentially we've got all of the various tools that you would use when you're developing your your data warehouse, such as your SQL scripts and your notebook files in Spark and your data flow jobs in Data Factory and your Spark jobs, right, for orchestrating your Spark clusters, and finally your Power BI for the output. Now, when we look at SQL on demand, right, now we have this ability to, very similar to, say, an Athena product in AWS or, Databricks, where you can run compute on demand, and it allows you to actually have a query-based pay-per-use model, which can help you dramatically reduce the costs over needing to have a provisioned model where the compute is running all the time. So, we get a lot more flexibility with this, and we have the querying on demand for the SQL platform and the Spark platform. Next, when we look at the notebooks in our interface for using those Spark clusters, we've got the ability to use a few different languages, and we can connect in. We can use temporal tables, and then we can export the results. So you'll see that in the interface here, you can right-click on a file that's in its storage account, and you can run a notebook against that file without ever having to load it, because it'll do it for you in the background. So it will write the initial code in that cell in the bottom window, where you can see that you're connecting in to that external source to be able to run your data. And then you've got the ability to visualize that data right in the window for a quick snapshot, but then also continue that along and use it as part of your workflow. And then lastly, from an interface standpoint, you've got the ability to use 4 different choices of languages. So you've got PySpark, you've got Scala, you've got .NET Spark, which is C#, and you've got Spark SQL. So C# is kind of the real new one here that wasn't available in some of the previous products. And so that's really exciting that we have a .NET framework for the Spark clusters. And so again, what is your language? What are you comfortable with? What is your preference, right? So there's that age-old debate of Python versus Scala. What is that? What is your preference? What is your team strongest with? What is your coding standard? So we've got a lot of flexibility there. And then that gets extended out to your Azure machine learning. So same, you can run your machine learning jobs on Spark clusters. You can load your libraries. We've got the AutoML classifier that belongs right as part of the Azure ML workspaces, and the ML suite for doing your scoring and running and training your models, and being able to output the information as part of your overall workflow. And then finally, you can output that to Power BI, right? And so you can see right there in the interface, you can build a Power BI report, and you can publish it, and you can do all the visualization that you need to, all in one interface. So when we look at what was announced yesterday at Build, so from the Synapse SQL standpoint, you've got the ability to use your SQL data pools, which was formerly that Azure SQL Data Warehouse product. And these are your compute on demand for the massively parallel processing system for running the data across the multiple compute nodes. You've got some things like predict scoring and your bulk load wizard. So we're offering some more wizard-based things. We saw the right click and run a query on demand if you need to, and we can do some CSV schema inference. This is just a subset, but there's a lot more capability that's being released, and you can go ahead and get that right from the portal today. Next, you've got the Synapse Spark, where you're running the Spark node in the background. One of the surprises for me, which was really cool, is that the Delta Lake is available. That was one of the things I wasn't sure wasn't going to come out in this public preview version, but similar to the Delta Lake that's available in Databricks, we've got the Delta Lake available in Spark because it's a Spark technology, and we've got that available now to be able to use in Synapse Spark. Also, you get common data model support, the .NET framework we talked about, some samples and template code generator for notebooks. Our pipelines, again, that orchestration and transformation piece that we talked about in Azure Data Factory is all part of this same window, so you don't have to go back and forth to multiple tools. You've got the trusted service for things like storage and Azure Key Vault. It's using the Azure Fabric in the background to be able to connect into all those things. And you do have some pretty good controls around security and stuff to be able to manage how that works, as well as those private endpoints for connecting in securely and making sure that the right people are getting to the data that should be. And then finally, we've got Synapse Studio, which is the overall interface that we're using. Cosmos DB with Synapse Link was another one of the exciting announcements yesterday that was kind of not really as much on the radar. So this allows you to use Cosmos as one of your compute on demand options to be able to run some of those queries on demand. You've also got things like the external table wizard and the monitoring and management. You've got the Spark job debugging and a lot of great capability here, as well as granular workspace with RBAC controls to be able to control who can do what. So very exciting stuff that came out. And so we'll jump in and do a quick demo. I've got about, looks like 9 minutes if I can save a little bit of time for questions. So when we bring up our interface here, so the first thing I wanted to show is that when you go in and you search for Azure Synapse, you can see that we've got two different things here, right? So we've got Azure Synapse Analytics, and Azure Synapse Analytics, formerly SQL DW. So you want to create a new workspaces pipeline when you create a workspaces preview when you create a new service. And so after you create that, it will then spin up and it will allow you to connect into your Synapse Analytics workspace. So this is my workspace. This is the screen that you get when you load this. When you load the Synapse workspace, you can see it's got its own dedicated web search, right? Web URL. So you go to web.azuresynapse.net, and that will prompt you immediately to connect to your workspace. And so you have to set it up first in the portal, and then you go in, and this is how you manage it. You can see as I open it up, you can query some sample data. You're picking your pool that you want to pick from. This is one that I previously provisioned. You can create a new SQL pool if you want to, and then you've got some high level things kind of giving you an idea of what it's doing. You can take the tour of the studio if you want, and then you can just close this out. Now, again, all in the same interface. I've got the ability here to do my development, to bring in my outside sources, and do my analysis and run my jobs, and then finally do some visualization as well as monitor and manage it. So from my home screen here, you can see I can create new things as I want. So just for instance, if I wanted to say import some data, I could pull in and pull in a custom file here, right? A JSON file. If I wanted to import something like an Azure Data Factory job and bring it into my Synapse workspace or something along those lines, I have that ability here to pull that in. But then if I wanted to, say, ingest some data, it's going to pop up this wizard automatically. I'm going to name it, and then where am I connecting to, right? What are my options? So if I wanted to connect to, these are things that I already have created, but if I want to create something new where I'm connecting to, again, this is very similar to the Azure Data Factory interface with, about 90 connectors today, where you can get in and connect to a lot of different things, whether they be on-prem or in the cloud. And so, really, really interesting stuff here that you get the ability to connect into very simply. It'll have you set up your source and your destination, where you're pulling the data from, where you're sending it to, some various settings as part of that. I got to get through it, so we'll can't skip that. But a lot of options here as you want to ingest that data. So then after the data has been ingested, you'll see that, I've got just the database server. It's doing a refresh now, but I've got my Synapse SQL pool. See, it's identified there. If it were a Spark pool, it would also be identified. What are my tables in here? Things like that. And then as we go into our, here you could also connect in. So if I connected to a data set that I already have existing inside of, say, Azure Data Lake Storage, I've got all these file types that I can connect to, and this would be to import the data. Whereas you can see I've also got the ability here to connect to an external data source, right? So you've got this ability to query off of an external source, and that is going to ask you where you're getting the data from. So we've got the Mongo API, the SQL API, both in Cosmos, and you've also got Data Lake Store Gen 2 to be able to connect to. Further down, we've got our development hub, which allows you to create your new SQL scripts, your notebook files, your data flows, and your Spark jobs, right? So these can all be created here, and you can import, again, if you have, say, a notebook file, got JSON, we've got a bunch of different options here. You can pull those in as you need to from your previously created jobs, right? So the big thing is that we don't want to see any of the previous effort wasted. So if you ran Data Factory, if you have notebook jobs and those kinds of things, you can pull those in and import them into this interface. Then we've got our orchestration. So you can create your new pipelines. You can do a copy data activity. So this will create the pipeline for you. It's wizard based, or you can create a pipeline, and that'll basically pop up our familiar Data Factory window. It kind of shows you, the various jobs that you can do. You can run Databricks notebook files or jar files or Python files. You've got Azure Functions. You've got your batch service. You've got HD Insight capabilities in here for things like Hive jobs or Pig jobs, those kinds of things. You've got some loops and switches and those kinds of things, and then the Azure machine learning capabilities built in right here, so you can do your scoring as part of a Data Factory pipeline. And then, from when we go to monitoring and management, right? So there you can monitor your jobs. You can see when the jobs are run. You can look at your Spark jobs, your SQL jobs, and the various activities. It's going to give you fine-grained detail on that. And then finally, your management. So you can spin up your new pools here, right? So I've got my SQL pools. I've got my Spark pool. Link services. So if you think of your connection strings in a SQL environment, you can connect into those. Job triggers, integration runtimes, those types of things, right? So a lot of great capability here, and this will only grow over time, as it is only a public preview, and as we go into more GA and stuff like that, they'll be constantly adding new features into here. So really ask the question, what does Azure Synapse mean for my modern data warehouse? And really the answer is it offers you a great amount of capability all in the same interface. And so if you've done any previous work with Azure Data Factory or any of the other tools, that you had to bounce around to the different interfaces, to go manage your SQL cluster, or the Spark clusters didn't exist, but now those are available, or your Data Factory jobs. Now it's all integrated in that same interface. So it gives you a lot more control, makes you that much more efficient to to all be integrated in that same workspace, and that way it just really kind of changes everything that we're used to have to use all these different tools to be able to bring that all into one place. Again, there's my contact info. So if anybody has any questions that I don't get to now, I'm going to look at the questions here in the chat. If anybody has any questions, happy to get to them. I'm going to jump into those now. So what do we got here? Where is it? Okay, in the chat. Okay, question. Could you provide a little more detail on what is Delta Lake? Yeah, so Delta Lake is if you want, you could call it a Spark version of being able to handle like a transaction log in SQL. So essentially, it provides ACID transactions like you'd have in SQL, and it gives you the ability to essentially make sure that you go through that sort of ACID test, if you will, to make sure that the jobs are written and committed, so that you guarantee that the transaction is processed when you do something on a Spark cluster. So this is something that Databricks introduced in their product probably about a year ago, little less, and then now it's being also brought into the Synapse Spark clusters. So with that, I don't see any more questions. We do have a little more time, so if no more questions come through, I guess we'll wrap it up from there. Okay, well, I'm going to call it a day. I appreciate the time, everybody. Thanks very much. And if there are any questions, definitely feel free to follow up with me and ask anything else as they come up. And thanks again for watching. Have a great day.